Good afternoon once again. We are back with another video still under the integration of trigonometric substitution. So in this case, we have here our example: evaluate integral of square root of 9x squared minus 4 all over x dx. Now we know that we can rewrite this one as equivalent to square root of 3x squared minus 2 squared all over x dx. So as you can see here, this comes in the same format as this one. So meaning to say, 3x squared is 3x squared minus 2 squared is equivalent to x squared minus a squared. Now x squared here is 3x in our example. So meaning to say our 3x can be replaced by our a secant theta. Now our a from the example is equivalent to 2. So meaning to say 3x is equivalent to 2 secant theta. Now we also have to find the value of our x. So to find the value of our x, we can divide both sides by x, by 3, so that we can isolate x. So meaning to say x is equivalent to 2/3 secant theta. Now, after we find the value of our x, we also need to find the value of the derivative of our x. So meaning to say, the x is equivalent to 2/3, and then the derivative of our secant, which is secant theta plus tangent theta d theta. Now, after we got these values here, we can already substitute this one into our equation. So from this one, we have integral of square root of 3x. 3x is equivalent to 2 secant theta. So meaning to say, we can also substitute that here. 2 secant theta squared minus 4. And then the value of our x is equivalent to 2/3 secant theta. So meaning to say, we have all over 2/3 secant theta. And then the dx is equivalent to 2/3 secant theta plus tan theta d theta. So we have to put that here as well. So we have 2/3 of secant theta plus tangent theta d theta. But as we know, we can cancel this term as well as the denominator, right? So now, what we have left is the integral of 4 secant squared theta, which is this one, minus 4 multiplying with the remaining term. So we have tangent theta d theta. So afterwards, we know that there is a common term in this equation. So meaning to say, we can factor those common. So the common ones is 4, right, from this one. So meaning to say, we can factor 4 from the equation. So that gives us 4 times secant squared theta minus 1. And then copying the remaining term, we have tangent theta d theta. Afterwards, we can already find the equivalent of secant squared theta minus 1. As we know, there is a trigonometric identities, basic trigonometric identities, which is equivalent to secant squared theta minus 1. And that is tangent squared theta. And then copying the remaining term, we have tangent theta d theta. Afterwards, we can already find the square root of this this term. So we have square root of 4 is 2, and then square root of tangent squared is equivalent to tangent theta times this one. So we have tangent theta d theta. Now we know that 2 is a constant number, so we can put that outside our integral symbol. And then tangent theta multiplied by another tangent theta, that is equivalent to tangent squared theta d theta. Afterwards, we can also find the equivalent. As we know from earlier, tangent squared theta is equivalent to secant squared theta minus 1. So perhaps we can also change that back to secant squared theta minus 1. So we have secant squared theta minus 1, then we have the d theta. So integrating this one separately, since it is separated with an operation in between, so we have 2 integral of secant squared theta minus 2 integral of d theta. So we have secant squared theta is equivalent to tangent theta in integral calculus. Now, negative 2 integral of d theta is equivalent to 2 theta plus c. But as we know again, theta is not our original variable, so meaning to say this is not yet our final answer. We need to return this back to its original variable, which is x. So meaning to say, from the substitution that we had earlier, we have that was 3x is equal to 2 secant theta. Now, we know that secant theta from this equation is equivalent to 3x over 2. And from our trigonometric course from last year, we know that secant is equivalent to hypotenuse over adjacent. So, meaning to say hypotenuse over adjacent. So from here, we can see that 3x is our hypotenuse, 2 is our adjacent. So if we plot that one in our right triangle, having this side as our angle, hypotenuse, meaning to say this one, this side is our hypotenuse, which is equivalent to 3x. And then our adjacent is this side, so we have the 2. So meaning to say this opposite side is equivalent to 3x squared minus 2 squared. So if we, to get the value of our tangent theta, we can say that tangent theta is equivalent to opposite over adjacent, right? That is TOA from SOHCAHTOA. So we have opposite over adjacent. So from our right triangle here, opposite is this side, so meaning to say that is equivalent to 3x squared minus 2 squared, and our adjacent side is equivalent to 2. So we have 2 here. Now from our answer, we also need to find our value of theta. So from here, theta is equivalent to arctan of this one. So we have theta is arctan of square root of 3x squared minus 2 squared divided by 2. So plugging that into our answer, we have here 2, and then the tangent theta is equivalent to this one. So we have square root of 3. So we have square root of 3x squared minus 2 squared squared all over 2 minus 2, and then the theta, which is equivalent to arctan of square root of 3x squared minus 2 squared all over 2 plus c. Now we can cancel 2 here, so meaning to say that is equivalent to square root of 3x squared minus 2 squared minus 2 arctan of square root of 3x squared minus 2 squared all over 2. And also that is equivalent to square root of 9x squared minus 4 minus 2 of arctan square root of 9x squared minus 4 all over 2. Then we have the plus c here. So meaning to say this is now our final answer. So I hope you understand from the lesson for this example, and I will be pasting here the equivalent solution I also made earlier. So this one for better quality answer. So I hope you understand, and thank you so much for watching, and see you around in my next video. Thank you. Bye-bye.